In today's lesson, we're going to learn how to solve the triangle. And that's new vocabulary that you've probably never heard before. When you solve a triangle, what you find is the side lengths and the angle measures that you don't already know. So typically when you're solving a triangle, you'll be given at least one side length and an angle measure, or two side lengths and just the fact that you have a right triangle. And you're going to have to use a combination of Pythagorean Theorem and Trigonometry to find the missing parts. So in triangle ABC right here, we were given that the hypotenuse was 19. The measure of angle C was 34 degrees, and we were asked to solve the triangle. So when we solve the triangle, we just find the missing parts. So we already knew that angle B was a right angle. So since angle B is a right angle, 90 plus 34 gives me 124 degrees out of 180 in a triangle. So if I take 180 and subtract 124, that leaves me 56 degrees for angle A. It does say to round to the nearest hundredth, so I probably could rewrite that as 56.00, but I think that at this point right here, it'll probably be fine because this is given as a whole number as well. In order to find these other two sides though, I'm going to have to break out some trigonometry. So I know my hypotenuse is 19, and I'm going to find this length of segment AB, and I'm going to call it X. So if I call AB X, I know that it's opposite the given 34 degree angle. And I already have my hypotenuse. So when I use opposite and hypotenuse, that's going to be a sine function. So sine of C is equal to opposite over hypotenuse. Sine of 34 degrees is equal to X over 19. I multiply by 19 on both sides, round to the nearest hundredth, and I get 10.62. To find Y, I chose to use cosine. I already knew the hypotenuse, I already knew the 34 degrees, and I called segment BCY. So since I have adjacent and hypotenuse, I say cosine of C equals adjacent over hypotenuse. Cosine of 34 equals y over 19, multiply by 19 on both sides, round to the nearest hundredth, and get 15.75 equals y. I have another example where I'm given two side lengths, and I'm asked to solve the triangle. So whenever we're solving a triangle, we could use Pythagorean Theorem, we could use trigonometry, we could use some sort of combination thereof. I chose to find the length of segment EF first. So when I found the length of segment EF, I used Pythagorean Theorem, where a squared plus b squared equals c squared, a and b being the lengths of the legs, c being the length of the hypotenuse. So I have 5 squared plus x squared equals 14 squared, which is 25 plus x squared equals 196. I subtract 25 from both sides, take the square root of both sides, I get x equals 13.08 because my directions asked me to round to the nearest hundredth. At that point, I decided that I should start using some trig to get angle measures. I already know that angle E is a right angle, so I'm going to find, say, angle F. If I find the measure of angle F, I have my hypotenuse, and I know that this 5 on segment ED is opposite angle F. So when we work with opposite and hypotenuse, we choose to work with sine. Sine of F is equal to opposite over hypotenuse. When I substitute in that opposite is 5, the hypotenuse is 14, I take the inverse sine of both sides, and I get the measure of angle F equal to 20.92 degrees. One way to get angle D right now would be to add 90 and 20.92 and then subtract that sum from 180. Another way would be to just use trigonometry again. With angle D, the 5 is actually adjacent to angle D, and 14 is still the hypotenuse. So when I'm working with adjacent and hypotenuse, I can use cosine. Cosine of D is equal to adjacent over hypotenuse, where adjacent is 5 and hypotenuse is 14. I take the inverse cosine of both sides, and I get the measure of angle D equal to 69.08 degrees. Hopefully, you should see that these two numbers add up to 90 so that we end up with a grand total of 180 degrees in our triangle. I attached a worksheet to today's lesson for you to try solving the triangle. Good luck with those.